beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late-night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds. The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication, we never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late-night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. every life receives the respect it deserves, and a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds. The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication, we never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves, and a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds. The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication, we never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds. The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication, we never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent cloud network ensures shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. and a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds. The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication, we never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data
Huawei Cloud Fabric 3.0 solution. Unleashing computing power with new Ethernet session at Huawei Connect 2021. Having experienced the agricultural, industrial, and information eras, the world is now entering the computing era, a new era of digitalization. In today's session, we will explore the development trends of data center networks in this new era and how Huawei's hyper-converged data center network unleashes 100% of computing power. First of all, let's invite Mr. Brad Casemore, IDC's Vice President, Data Center Networks, to give a speech. The title of his speech is Ethernet as the Basis for a Hyper-Converged Data Center Network. Let's welcome.
Thank you. My name is Brad Casemore, and I'm Research VP for Data Center and Multi-Cloud Networking at IDC. It's my pleasure today to speak to you about how Ethernet has evolved to become the basis and the foundation for hyperconverged data center networks. So let's explain the context and exactly what's happening today, and then we'll go into how Ethernet has evolved to become this hyperconverged data center network. Today, data center networking involves separate technologies and networks that meet different sets of requirements. We have an Ethernet network that supports general purpose computing requirements. We have a fiber channel network that's often in place to support storage networking. And in some enterprises and organizations, we also have an InfiniBand network, which supports high performance computing. In addition, most organizations today, and IDC sees organizations increasingly having a need for a DCI network or other data center to cloud connectivity to support hybrid IT and multi-cloud. Of course, a DCI network being data center interconnect to provide Ethernet-based connectivity between data centers. So there's a need now to extend networks, digital network infrastructure, across an increasingly distributed application landscape as we see more applications move to multiple data centers or to clouds. Why do we have multiple data center networks, though? So, it's an obvious question. We've just explained that these exist, but why are they there? The simple answer is that requirements and use cases are different, and they have different needs. We have Ethernet, of course, that's in place widely and pervasively for general purpose compute. In these environments, host virtualization technologies such as VMs or containers are supporting applications. They're providing the infrastructure for the applications. And they require high bandwidth and fast data planes for east-west traffic between servers in the data center. Fiber channel is in place for storage networking. Storage media such as hard disk drives and solid state drives are interconnected through these storage networks, and they must provide high levels of IOPS and extremely low latency connections between server hosts and storage arrays. So there the focus is on very low latency to support the storage workloads, dealing with things like elephant and mice flows, etc. And we have InfiniBand for HPC. These environments run highly computationally sensitive, latency sensitive workloads, including big data analysis and advanced simulations. Here, extremely low latency is prized because they're dealing both with batch workloads and real-time workloads on an almost continuous cycle. The problem, of course, with having these multiple networks is that they cost more. You have 3 networks, so you're dealing with 3 different sets of procurement, deployment, and operations. And that requires CapEx outlays, separate CapEx outlays, and a greater degree of operation specialization in terms of your personnel. They need to know about the protocols and technology-specific expertise associated with each technology. Tools are also separate in this model, and that results in redundant costs for tooling. If we look at the worldwide data center networks market today, you can see some of this reflected in the data, but overwhelmingly, because of the need for Ethernet in, of course, the general purpose compute network in the data center, we can see that Ethernet switching, OEM, which is provided by name brand switches, and ODM, which is provided by white box manufacturers, make up the vast majority of the market collectively. We see the market for fiber channel switching up there in the yellow slice of the pie, almost 1.6 billion. And then InfiniBand switching is a smaller market, specialized market for high performance computing. But you can see from this slide that Ethernet switching is certainly more pervasive in the market, and it benefits as a result of that from economies of scale and the innovation that occurs within that larger ecosystem. I mentioned the Ethernet ecosystem, and it's certainly one of the reasons why Ethernet's continuing evolution makes it a great candidate for hyperconverged networks. It not only makes those networks possible, but certainly makes them viable for the use cases I mentioned. Ethernet already has a significant bandwidth advantage over the other technologies. We have 400 gigabit Ethernet today, and we have 800 gigabit Ethernet on tap, and we have plans for speeds above 1 terabit in the future. So Ethernet is continuing to widen the chasm and extend its advantage over the other technologies in terms of bandwidth and throughput as we move forward. Ethernet's also made impressive advances in achieving low latencies and losslessness. We've seen this through advances such as RoCE and the various NVMe over Fabrics Ethernet alternatives that are moving into the market now and will become more pervasive in the years to come. And that means, of course, that Ethernet is well placed to address the SAN and HPC use cases that I discussed. The Ethernet ecosystem is of course, vast, as I mentioned, and innovations are already continuous, and they'll continue at that pace well into the future. The other technologies by contrast, I mentioned Fiber Channel and obviously InfiniBand, have smaller communities and as a result, less active ecosystems. They are more tightly controlled by a small number of vendors. Ethernet part of the reason why it has such a thriving ecosystem is standards-based and open. And of course, that gives users choice and flexibility and interoperability as they evolve their Ethernet networks. It means they can mix and match vendors, they can use overlays and underlays with Ethernet, and they have a lot of flexibility in terms of how they design and build their data center networks well into the future. Another aspect that's worth mentioning, I mentioned overlays, is the advanced network automation capabilities you see with Ethernet. You see a range of network automation that's available for Ethernet networks, SDN and IBN, intent-based networking. We have all sorts of network automation tools that work well on Ethernet networks, and these are continuing to evolve as well. These tools for network automation handle not only day 0 and day 1 scenarios, but day 2 and day n scenarios. So they are built to provide network automation and intelligent network automation throughout the network life cycle. A big piece of that, of course, is also pervasive analytics and telemetry and visibility tools that are part of the Ethernet ecosystem as well. And all of these provide advantages as applications move to cloud-native application architectures, and we have more applications running in distributed environments such as hybrid and multi-cloud. These are all advantages that are helping Ethernet evolve into this hyper-converged network technology. And we can see certainly, again, coming back to the numbers, this is worldwide data center Ethernet switch revenue by speed. And the point of this slide is to show how Ethernet continues to evolve. You can see we had 1 and 10 gigabit Ethernet back in 2016 as very prevalent technologies, and now we're seeing the rise of 100 and now 200 and 400 gigabit Ethernet networks as we move into our forecast years up to 2025 here. This is a testament to Ethernet's continuing evolution, viability, and really its perseverance as a technology that continues to move forward unstoppably to address new requirements, new and old requirements, and a number of new use cases as well. Enterprise interest in converged and hyperconverged networks. You might say, okay, it's great that Ethernet has all of these features, but is there interest in really creating a converged or hyperconverged network based on Ethernet? Well, enterprises have learned from what hyperscalers and digital natives have done in their data centers and with their data center networks. And they've learned from what those industry leaders, those cloud giants and digital natives, how they've used Ethernet for not only general purpose computing, but for storage networking and where applicable, HPC as well. Hyperscalers, of course, also use Ethernet for DCI and wide area use cases. Think about the connectivity between the availability zones in their regions all around the world. Enterprises see the capabilities and benefits that converged and hyperconverged networks provides. They see what these hyperscalers and digital natives are doing, and they're increasingly interested in using Ethernet more comprehensively for not only general purpose computing, which is typically how they use it today, but also for storage networking. We're seeing more of that, and we'll see even more of it as we move into the future, and even for HPC. And they're certainly going to use Ethernet rather than the other technologies as they look at those sort of hybrid connectivity and multi-cloud networking use cases. So the data center interconnect use cases and multi-cloud networking use cases that I mentioned, and the connectivity to clouds is also going to be done increasingly and exclusively through Ethernet. So how interested are enterprises in having converged data center networks? Well, we asked a very specific question in a survey. We asked, how likely is your organization to deploy, and these are enterprise respondents, a hyperconverged IP data and storage network that is lossless, low latency, and high performance in the next 12 to 24 months? And you can see that there's a very healthy respondent base. It's getting up to, depending on how many data centers you have, it's getting up to close to 50% in many cases. And the percentage certainly will increase over time. So there's great interest in this already. Significant portion of the market has considerable interest in a converged data center network with attributes such as losslessness, low latency, and high performance. If we look at the benefits of having that, and of course this is why they're interested, There are a range of benefits. You have cost savings that result from network consolidation. You have a single Ethernet network, and that reduces costs associated with having redundant network infrastructure. And as I said earlier, the savings come not only in the procurement, you have one network rather than three, but also through the design stage, the build stage, and the ongoing operation of the network. You also eliminate the elimination of redundant networks also simplifies and improves the efficiency of network operations and management. You can take advantage of those automation tools I mentioned that exist in the Ethernet community. And as a result, your network operations become more agile and flexible and more attuned with the needs of the business. So you're able to move more at the speed of digital business than you could before. The tooling around network automation, SDN, network virtualization, and cloud orchestration for Ethernet networks certainly surpasses that available for any other network technology. The same is true of tooling that applies to network management, configuration management, ongoing network monitoring, network analytics and telemetry, and network visibility and observability. The Ethernet ecosystem is moving at a frenetic pace in these areas and will continue to innovate. Automated network operations across that full life cycle as a result of the technologies I mentioned that span the life cycle leads to day zero planning that is more efficient, leads to deployment and certainly provisioning that is faster. It leads to ongoing maintenance and closed loop change management and optimization. So think about day two, troubleshooting and remediation, as well as ongoing optimizations to the network. All of this is becoming increasingly important as we move to modern application network architectures and we move to hybrid environments and multi-cloud environments. Root cause analysis as a result of what is available for these Ethernet networks can be achieved quickly, and that leads to faster troubleshooting and remediation. That in turn yields more uptime and greater availability, and that is certainly key to delivering applications and services in the digital era. Closer alignment of network infrastructure and the network operations team with applications and services are becoming essential to the digital experience. And we can see, if we consider the last few benefits that I talked about, how this is really going to bring networking up to speed with DevOps and the needs of developers who are increasingly, with their applications, driving digital innovation and digital transformation in enterprises worldwide. Key takeaways as you think about what I've said and what I've covered in this presentation. Well, traditionally, separate networks have been required in the data center due to varying requirements. We've had general purpose Ethernet for the compute within the data center and providing server-to-server connectivity. We've had storage networks, which have often used fiber channel for fiber channels losslessness and low latency. We've had HCI networks that have often used InfiniBand for high-performance computing requirements. Each network, though, had to be separately procured, deployed, and managed, incurring parallel CapEx and OpEx costs. So basically, you had redundant costs because you had separate networks. Ethernet advances have made it a viable candidate to serve as the basis and the foundation for a hyper-converged data center network that can address not only general purpose computing as it does today, but also storage networking and high-performance computing. Additionally, Ethernet, already widely deployed in the wide area network and the metropolitan area network, can address and does address DCI and hybrid and multi-cloud requirements. And we'll see Ethernet used even more pervasively as more enterprises embrace hybrid and multi-cloud in the future. Enterprise interest in using Ethernet as the basis for converged or hyper-converged data center networks is growing, as we saw. And it will continue to grow as Ethernet advances further and the benefits of all Ethernet data center networks are more widely recognized. There's no question that Ethernet has gone from strength to strength. It has had already a very long and fruitful history. And there's no reason also to think that that history is coming to an end. We see a very exciting new chapter for Ethernet as we move to increasingly converged and hyper-converged Ethernet data center networks. Thank you for your time, and I now hand it back to Huawei for the rest of the program.
Thanks, Mr. Brad Casemore, for your thought-provoking speech. Next, let's invite Mr. Roger Marks, Chair of IEEE 802 Network Enhancements for the next decade, to share insight into the evolution of intelligent, lossless data center networks.
Welcome to this talk on intelligent lossless data center networks. My name is Roger Marks, and I'm chair of the IEEE 802 Network Enhancements for the Next Decade Industry Connections activity, otherwise known as NENDICA. In June of 2021, IEEE published the IEEE 802 NENDICA report on intelligent lossless data center networks. This was the second of two NENDICA reports addressing data center networks. I'd like to highlight some of the aspects of the report in the talk today, and also let you know about the new Ethernet networks that are coming in the future. In our world, data is everywhere, and the amount of data has overwhelmed our ability to understand it. Machine learning AI has become the common tool to make sense of the data. However, machine learning demands vastly more data for training, in addition to the data for making decisions. Machine learning requires massive computation on massive data sets. Performance is critical so that solutions arrive when they're needed and decisions can be made in real time. Data centers are centralized regions of data and computation. On the other hand, within the data center, the data and computation are widely distributed and shared. Orchestrating the data flows between the storage and computing resources is a critical success factor. The DCN needs to, or the data center network, DCN, needs to link the storage and computation elements together without friction and without significant delay, turning the data center into a real thinking machine. The NENDICA report outlines emerging data center requirements. For example, in machine learning training, model parallel and data parallel computing is highly dependent on network performance. Model synchronization steps bring the computed values together at a parameter server simultaneously. This results in incast congestion at the egress port to the parameter server, as all of the model synchronization data is transmitted to that server simultaneously. The congestion at the egress port can spread and result in head-of-line blocking of other traffic. So flow completion time becomes uncontrolled with high tail latency. Also, new storage technology is becoming available, and storage has evolved from hard drives to solid-state drives to storage class memory. The static latency has fallen by orders of magnitude with this progress. NVMe over Fabric uses NVMe for network storage, and the network is becoming the latency bottleneck, especially dynamic latency due to congestion. Also, RDMA over Converged Ethernet, remote direct memory access, in terms of RoCE v2, has become prevalent and now supports direct RDMA among GPU memory. This reduces delays inside the server. And so even more, the network becomes the latency bottleneck. RDMA and TCP need to share the converged Ethernet fabric and don't always coexist happily. The NENDICA report highlights challenges to the data center network. For example, there's a trade-off between high throughput and low latency. Transmission throughput increases when queues are allowed to grow large, but the latency suffers due to the large queues. So how do we optimize this result, considering, for example, flow completion time as a target? One way to eliminate congestion loss is to use priority flow control, or PFC, which was previously developed in IEEE 802. But in multipath data center network topologies, such as you'll find in a data center, PFC deadlocks can arise. Congestion control is complicated in the case of mixed transport, as you'll have on a converged Ethernet fabric that supports both TCP and RDMA traffic. These data flows can interfere, for example, with congestion control using buffers that are shared by ports. And finally, congestion control algorithms, such as PFC and ECN, require parameters to be set as part of the configuration. And optimum performance requires that those parameters be set optimally, but the optimal values are not known. The Nendika report highlights new data center networking technologies that are coming into play. For example, hybrid transport, which combines two approaches: the sender-driven transmission with simple rate control feedback, as we might see in many data center networks, along with receiver-driven transmission with transmission grants generated by the receiver. And in hybrid transport, these two are combined in an optimal or preferred way. In addition, it's possible to address PFC deadlock, preventing it using topology recognition. It's possible to apply improved congestion notification methods, intelligent ones, and adaptive congestion control optimization. The Nendika report on intelligent lossless data center networks presents a holistic set of innovative solutions. For example, new hybrid transport protocols to balance the high throughput and low latency communication needs of AI and machine learning. New topology recognition algorithms to prevent PFC deadlock. Shortening the congestion notification feedback cycle by enabling switches to supplement congestion signaling. And simplifying switch buffer threshold configuration using adaptive AI models with telemetry. Such innovations, openly standardized, can advance the use of Ethernet as the primary network fabric for modern cloud-based high-performance data centers, with benefits in cost as well as network performance. The Nendika report on intelligent lossless data center networks was completed with the support of many individuals representing significant industry players in the intelligent lossless data center network industry. Some of them are listed here, and many are affiliated with Huawei. Now, beyond the intelligent lossless data center networks, I'd like to talk about the new Ethernet network. Lossless Ethernet with PFC optimization is a critical first step. The Nendika work has led to the initiation of a new standards project on congestion isolation, 802.1 QCZ, and it may lead to additional standardization projects. Future data center networks demand high performance, higher throughput, extremely low latency, and higher reliability. High-performance applications are converging in data centers. The data center needs to be oriented around a large-scale performance-sensitive network that unites high-speed storage and distributed computing. Ethernet will become more capable to support evolving requirements. Just as deterministic Ethernet has developed for specific industries such as automotive, industrial, and aerospace, discussions on low latency interfaces and high efficiency forwarding are beginning in IEEE 802. Evolution of Ethernet for advanced networking, including at the architectural level, is coming, fully transforming Ethernet networks from best effort to performance sensitive. These new Ethernet networks will bring the benefits of standardized commodity Ethernet to performance sensitive applications. Thanks.
Thank you, Mr. Roger Marks, for your insightful sharing. On the next topic, let's welcome Mr. Luo Zhanggan, Marketing Director of Huawei's Data Center Network Domain, to show how Huawei's Cloud Fabric 3.0 Hyperconverged DCN accelerates digital transformation across industries.
Hello, everyone. I'm Jiang Gan. Today, I will introduce the Cloud Fabric 3.0, the hyper-converged data center network solution, accelerating the digital transformation across the industries. Nowadays, the digital technology has reached all the aspects in our daily lives and also transformed all the industries. Data center, which has supplies the computing power to the whole digital world, is becoming more and more important. I think it's as important as 5G in the industry. And also, with the digital transformation of enterprise, it also drives the innovation in the data center. The first is to be more open. Take the finance as an example. In tradition, the bank is moving from the mobile banking to the open banking. And that means in the future, there's no limit to do the banking services on the banking app. And now, even to do the split of your bill in the shopping app, or you can get a loan from the automobile selling apps. So that means banking services is embedded in all the scenario of consumption in our daily lives. And the network also should be more flexible to suitable for different scenario integration. And the second is to be distributed. In the digital transformation deepening, more data is generated and the data center scale much more larger, extend to cross multi-data center and even the multi-clouds. And this also requires a network to be managed by the unified platform to support the cross data center and even cross the multi-clouds. And the third one, with the introducing of the big data and AI, some new service, much more stable and powerful computing power to support the new services, such as the quantitative trading, because all these decisions need to be making in seconds. And also, we can see all these new requirements will bring new challenges to the data center. The first is we need to have the lossless connection in data center, but for the traditional Ethernet, it's the best effort working mechanism. And with the 0.1% of the packet loss in the network, it will reduce half of the computing power in the computing system. So can we have a network to eliminate the packet loss in the network? This is the first challenge. And the second, extend to the multi-data center and the multi-clouds. It always consists of different vendors' equipment and solutions. That means the management of each individual area is siloed. So between different vendors' network, how to do the interconnection, we need to do manually. These are the breakpoints in the service orchestration. So in that case, can we have a unified platform to manage the whole data center network to mitigate the different vendors' difference in our data center? This is the second challenge. And the third one, once we do the service orchestration to the different service platform, we need to do the customized development, and it always takes many time, always lasts for months to do the new platform integration. So can we provide our network as a resource pool to make our network to be ready anytime to be called by the service platform? So that means, can we provide our network as a service to the different service platform to speed up the integration? So the answer to all this challenge is we can. So with Huawei Cloud Fabric 3.0 hyper-converged data center solution, we can provide the lossless connection in the physical layer. So that means we can improve the storage performance and also the HPC performance in the physical layer. And for the management, control, and analysis platform, we can provide unified software to do the third-party device management and the cloud network orchestration. And in the service platform, we can define our service catalogs based on our atomic capability to speed up the integration with different cloud platforms. So let's take a little detail about the solution. So in the HPC scenarios, as we already eliminated the packet loss in the network, so that means we can unleash all the computing power. But in the tradition, the network is not participate in the calculation process. That means our switch is only doing the packet transmission. So I think it's a waste of resource. So with our latest solution, we have introduced a new feature called integrated network and computing. So that means our network can be participate in the whole calculation process. You can see from this picture, we can save the whole process into one step compared before they need 3 steps to do this one round of the calculation. So in that means we can save a lot of time to speed up all the calculation process. And we have tested in our lab and also in our customer environments. The result shows that compared to the traditional InfiniBand network, we can improve the computing efficiency and to speed up the job completion time by 18 to 30%. So that means we can improve the computing power efficiency in the data center. And the second scenario is for the storage network. As we know, for the traditional fiber channel, they can support only 16, maybe maximum 32 capacity. And this year, we have extended our lossless network from intra-data center into inter-data center. That means in the dual-active data center scenarios, we also can provide the zero-packet loss Ethernet services, and we call it is NOF Plus solution. So with this solution, we can replace the traditional fiber channel network by our 100G solution. So it can double the ILPS in the storage performance of the ILPS, and also they can reduce the latency between the application by half. So that is a huge improvement of the storage performance in the data center. And in the management platform, in the traditional is a siloed build. So the management tools is also siloed. There's no common platform can be managed all the different vendors' products. Interconnection between different DC and different clouds, we need to do manually. And this is very low efficiency and also may introduce some manual error in the configuration. So our iMaster NCE can provide the agile open container features. That means it can mitigate different interface of different vendors. We can use this one network platform to manage Huawei equipment and also other vendor equipments as a unified resource pool. We can provide the end-to-end network orchestration, simulation, and verification. And to the multi-cloud scenarios, we can provide the multi-cloud network orchestration called MDC features. And it can extend your network into different clouds, from the private cloud to the public clouds. So that means for all the clouds, we can do unified orchestration. And we can eliminate the menu configuration error. So we can reach 100% of the configuration accuracy. And also, by end-to-end automation, we can improve the service rollout efficiency by 10 times than before. That means we can use 1 day to do all the service configuration. And not only the orchestration and the configuration in the network, we also introduced the intelligent O&M feature into the multi-DC and the multi-cloud scenarios. So we can build our digital twin network in our iMaster NCE, and also we have introduced our knowledge graph technology to do the simulation of all the elements relationships. So it can handle millions of relationships, the configuration, and also like the flow status in seconds. Compared to before, we can provide 3 times more metrics to do the network health evaluation, and also we can do the proactive fault detection and the location. So its efficiency can improve by 20 times than the traditional solutions. And besides of that, once we want to integrate our network into different service platforms, we can use our network as a service feature to speed up the integration. So before, our customer told us they have more than 30K work orders per year for the network team to do the rollout. And the average for one engineer, they need to take more than 30 work orders per day. So it is very heavy workload for our engineers. And also, the engineer, they don't have the global service view of the service. So they need to do a lot of time to do the alignment with the service team. So the efficiency is quite low. And with our network as a service features, you can define your service catalog based on the atomic capability. So all these catalogs you can publish to and also you can do the reuse of all this catalog. And also you can do customize and redefine of the service catalog. So that means in the future, if you need to integrate with different service platform, you just need to call the service catalog and no need to use the customize to call each API in our network. So for this one, our customer can reduce the workload by 90%. So from 30K to almost only 1K workload per year. And also for the single service definition, they can save 70% of the communication time to speed up our new service to be online. Here is the portfolio to show how we can support our new features in the Cloud Fabric 3.0, the hyper-converged data center solution. So with the iMaster NCE and all series of our products, Cloud Engine switches, it can cover from GE to 400G, all the bandwidth, and from the small scale to the large scale. So if you have any interesting or requirements, you can contact our local sales team. They will be happy to do the customized solution for your network. And the last, I want to thank all the customers that support us to reach here. And in the future, we also will invest more in our innovation to bring a better and future-proof solution to all our customers. One more thing is, as a give back to the industries, Huawei has published a book called Data Center Network Architecture and Technologies. So with this book, it's compiled by our professional experts, and also is focusing all the hot technologies in the data centers. And also we share a lot of our experience in data center network planning, provisioning, management, troubleshooting, and analysis. So you can search the book name in the Amazon website to buy. We can offer both the electronic version and the printed version. So thanks for listening to this topic.
Thanks, Mr. Luo Zhan Gan, for your wonderful speech. Next, let's invite Mr. Kevin Tolley, founder and CEO of the Tolley Group, to interpret the Tolley test of hyperconverged data center network intelligent lossless solution.
Hello everyone, I'm Kevin Tolley, founder of the Tolley Group. For over 30 years, the Tolley Group has been a leading global provider of third-party testing services for ICT vendors. We've published over 1,250 reports for 250 plus IT vendors, including market leaders such as Huawei, Cisco, HPE, Oracle, VMware, Dell, Broadcom, and many more. In August 2021, Tolley evaluated the hyperconverged data center network intelligent lossless solution from Huawei and compared it to some other market-leading solutions. The evaluation focused on two scenarios, the NVMe over Fabric storage area network scenario and the high-performance computing scenario. Traditional data centers may be built on multiple fabrics, Ethernet for server interconnection, Fiber Channel for storage networks, and InfiniBand for high-performance compute clusters. With new developments of Ethernet, such as lossless Ethernet technologies, high-performance Ethernet NICs supporting RDMA and MPI, NVMe over RoCE all-flash storage systems, Ethernet-based data center network solutions started to replace Fibre Channel and InfiniBand solutions to provide equivalent or better performance. Furthermore, Ethernet solutions are typically more cost-effective. They are supported by more vendors. And 400 gig Ethernet switches are widely available on the market now, while current Fibre Channel switches typically only support up to 64 gig Fibre Channel ports. For all these reasons, modern data centers are moving from the multi-protocol mode towards converged all Ethernet. Based on the preceding considerations, Huawei launched the Cloud Fabric 3.0 hyperconverged DCN solution. It consists of two components: Huawei iMaster NCE, an intelligent network management and control system, and Huawei Cloud Engine, Ethernet data center switches. This solution provides many benefits, but today we'll focus on the storage and high-performance computing scenarios in this presentation. And we'll see how the Huawei Ethernet-based solution performs against a Fibre Channel solution in storage test cases and against InfiniBand in high-performance computing test cases. Let's first take a look at the NVMe over Fabric storage scenario. There are two major types of fabric, which are RoCE and Fibre Channel. Tolly engineers used the VDBench benchmark to test storage I/O performance and latency. The three solutions under test are two NVMe over RoCE solutions from Huawei and H3C, and one NVMe over Fibre Channel solution. The test bed is a typical small-scale centralized storage system with the Huawei OceanStor Dorado NVMe all-flash storage. Overall, for each of the two Ethernet solutions, there are 4 25 gigabit Ethernet links between the storage system and the hosts. For the Fibre Channel solution, there are 4 16 gig Fibre Channel links or 3 32 gig Fibre Channel links between the storage and the hosts. For each solution, multiple read-only, write-only, or read and write tests were run with the VDBench tool. The charts here are the results of the 512 kilobytes I/O size sequence read 1, 2, and 4 threads. As you can see, the purple bars, which represent the Huawei NOF Plus solution, demonstrated higher IOPS and lower latency than all other solutions in these tests. The first comparison is between the Huawei NOF Plus solution with 25 gig Ethernet links and the Fibre Channel solution with 16 gig Fibre Channel links. Both solutions use the same topology with the same number of hosts, storage LUNs, and links. Compared with a 16 gig Fibre Channel network, Huawei's 25 gig NOF Plus Ethernet network improved storage I/O performance by up to 93% and reduced the latency by up to 49%. The blue lines in the charts represent the percentage by which the Huawei 25 gig NOF Plus network is better than the 16 gig Fibre Channel network. The second comparison is between the Huawei NOF Plus solution with 25 gig Ethernet links and the Fibre Channel solution with 32 gig Fibre Channel links. This time the topology is a little different. To make sure that the total bandwidth is similar, the Huawei NOF Plus solution used 4 25 gig links and the FC solution used 3 32 gig links between the storage and the hosts. So the overall theoretical bandwidth is similar for both solutions. Compared with a 32 gig Fibre Channel network, Huawei's 25 gig NOF Plus Ethernet network improved performance by up to 28% and reduced the latency by up to 22%. The third comparison is between two NVMe over RoCE solutions from Huawei and H3C. Both solutions use the same topology with the same number of hosts, storage LUNs, and links. Compared with an H3C network, Huawei's NOF Plus network improved performance by up to 23% and reduced the latency by up to 19%. In order to replace traditional Fibre Channel storage networks, the Ethernet solution must also provide comparable features. One important ease of use and security feature in storage area networks is the zoning feature, which is supported by the Fibre Channel protocol. Tolly engineers verified that when using Huawei Cloud Engine Data Center Ethernet switches and Huawei OceanStor Dorado NVMe all-flash storage, the Huawei NOF Plus solution also supports the SAN zoning feature. Each SAN zone is defined by host and storage systems' IP addresses. Storage systems can establish connections to hosts in the same zone with plug-and-play support. Meanwhile, storage systems are isolated from hosts that are not in the same zone. Screenshots here show that the storage systems and hosts in the same zone can automatically establish connections. Once a LUN is created and mapped to a host, the host successfully reads and writes data on the mapped LUN. The last screenshot shows the IP addresses in each zone. High availability is obviously another important requirement in data centers. Faster switchover from component failures means less service interruption. This applies to storage area networks. Tolly engineers used the VD Bench test tool to run continuous I/O tests and evaluated the service interruption time due to link or storage module failures. VD Bench prints out the I/O performance every second. If the printout shows 0, we consider it as a 1-second service interruption. On average of 10 test runs, the Huawei NOF Plus network had 0-second service interruption for each failure, while the Fibre Channel network had 3 seconds and the H3C Rocky network had 8 seconds of service interruption. Overall, the NVMe over Fabric storage test results demonstrated 3 key advantages of the Huawei NOF Plus solution. First of all, storage area networks must be lossless, which means the traffic rate may be pushed down. Meanwhile, the network must be able to fully use available bandwidth for high throughput. Huawei NOF Plus solution's intelligent lossless DCN ensures 0 packet loss under high throughput. This is demonstrated in the high storage I/O performance results. Secondly, the Huawei NOF Plus solution supports fast failover within a second for link and storage module failures. And third, the Huawei NOF Plus solution supports the IP-based SAN zoning feature. Once the zones are configured on the reflector switch, they are automatically synchronized to all client switches. Connections are automatically established after hosts and storage devices in the same zone are connected to switches. Now, let's move on to the high-performance computing area. In this area, Rocky and InfiniBand are the 2 most popular compute interconnection protocols. Tolly engineers tested Huawei's intelligent and lossless Ethernet network and Mellanox's InfiniBand network. The high-performance computing tests include bandwidth and latency tests in a congestion condition, MPI benchmark tests, and HPC application tests. The first HPC test is the IB write bandwidth and latency test in an 8-to-1 congestion condition. Both solutions used 100 gig ports. The left chart shows bandwidth results. The yellow bars are the InfiniBand results, and the green bars are the Huawei Rocky results. As we can see, Huawei and InfiniBand's IB write bandwidth is almost identical for all frame sizes. The purple line shows the difference between Huawei and InfiniBand results. The difference is always within 3% for all frame sizes. The right side shows latency results. In this 8-to-1 congestion condition, the yellow bars are the InfiniBand results and the green bars are the Huawei results. As we can see, the Huawei solution has lower latency than the InfiniBand solution for all frame sizes in this congestion condition. The purple and yellow line shows the difference between Huawei and InfiniBand. Huawei's latency is up to 95% lower than that of an InfiniBand network. MPI benchmarks are popular to evaluate high-performance computing. Tolly used the OSU micro benchmarks and Intel MPI benchmarks to evaluate Huawei and IB Solutions' performance. The left chart shows all reduced results. In OSU micro benchmarks and Intel MPI benchmarks with OpenMPI, Huawei's latency performance is overall equivalent to that of an InfiniBand network. In the OSU micro benchmarks with Huawei MPI test, Huawei's latency performance is up to 15% better than that of an IB network when Huawei in-network computing is enabled. The right chart shows all-to-all results. For most message sizes, Huawei's results are better. In certain all-to-all test cases, as displayed in the right chart, Huawei's latency performance is more than 10% better than that of an InfiniBand network. Tolley engineers ran 10 different high-performance computing applications in meteorology, hydrodynamics, high-energy physics, molecular dynamics, and the automobile industry. In most applications, the performance of Huawei switches has less than 3% difference to the performance of the InfiniBand switches. In the CESM and PAM crash applications, the performance of Huawei switches is 17% higher than that of the InfiniBand switches in the test. Last but not least, we'd like to introduce the in-network computing feature of the Huawei solution. According to Huawei, this function transfers part of computing operations from computers to the network switch devices to reduce communications in compute clusters, thus significantly reducing network latency in HPC scenarios and improving computing efficiency. This feature was enabled in the OSU micro benchmarks with Huawei MPI tests. As we mentioned, the Huawei network provided up to 15% higher performance than the InfiniBand network in that test. So here comes the conclusion. Fiber channel is widely used in storage area networks, and InfiniBand is widely used in high-performance computing. While Ethernet now also supports lossless networks and having higher port bandwidth, cheaper pricing, and more robust ecosystem, and many more future-proof advantages, modern data centers are evolving into converged all Ethernet. But can Ethernet provide similar or better performance than Fiber Channel and InfiniBand? Our test results demonstrate that in many test cases, Huawei's Ethernet-based data center network solution can provide better performance than other solutions. More detailed results will be included in our test report. That's all for today, and thank you for watching.
Thank you, Mr. Kevin Tolley, for your remarkable sharing. On the next topic, let's welcome Mr. Wizard He, founder and CPO of Netis Technologies, to deliver a speech titled Netis and Huawei Business Level AI Ops Joint Solution.
Hi everyone, good day. I'm Wizard, the co-founder and the Chief Product Officer of Netis Technologies. In this part, I will bring you the Huawei Netis Business Level AI Ops Joint Solution. At the beginning, let me briefly introduce Netis. As the world-leading vendor of intelligent ITOM products, Netis headquarters is in Shanghai, and the overseas headquarters is in Singapore. Netis is the global partner of Huawei, council member of Financial Partner Go Global program. We provide AI ops solution for global customers. Netis' core technology was capturing the packets from the network, decode them based on more than 2,400 industry standard or private protocols for performance analysis. The technology is patented both in China and the United States. Based on that, Netis was recognized as a global co-vendor of performance analysis by Gartner at year 2017, and has been selected as the example vendor of AI in financial industry, example vendor of AI Ops from 2019 to 2021. Netis has served more than 140 banks. 15 of them are the world top 100 bank based on AUM, including DBS Bank headquarters. We also serve more than 50 securities companies, insurance companies, and many financial infrastructure customers as well, including AIA, MetaLab, and etc. And more than 200 customers in other industries, such as service providers, large enterprises, and the governments. As we know, digital transformation brings challenges to enterprise. Take financial industry, for example. Digital transformation caused several conflicts. First, there is a conflict between the stability and the speed. The financial regulatory authority requires stability, but the business development speed could not be slowed down. And the second one is between the technology and the business. While the business was iterating rapidly, the technology alignment to the business perspective was lacking. And the third conflict was between the skill and the development. While the business has developing, the requirements of the staff skills and the human resources were growing higher and higher. The solution to solve these conflicts is AIOps. As Gartner mentioned, there's no future of IT operation that does not include AIOps. This is due to the rapid growth of the data volume and the pace of change that cannot wait on human to derive insights. So NetEase provides a business-level AIOps solution, help our customers to solve these problems, which can cross traditional architecture and a cloud environment, cross devices and applications, and provide a unified, business-oriented, and intelligent operation and management analysis capabilities. Whether in a cloud environment or a traditional data center environment, third-party institutions or branches, all data can be collected and analyzed without intrusion in the business system. Based on that, NetEase provides analysis capabilities such as network, database, business, and operation performance analysis. And now, we integrated with Huawei iMaster NCE Fabric Insight. Even the device performance analysis can be provided. The objective of this integration is to build the business and the network performance analysis capabilities covering underlay and the overlay, and the quick identify and the locating problems. Therefore, we can make the vertical analysis from the business to network to devices, and if a fault happens, we could locate the problems only in 2 steps. So we prepare a demo. It's about a new online law system product. A new online law system was built in the bank and launched successfully at 0 o'clock in August 20th. The new system started providing online loan products, was launching and kept running well until 1912. When IT department was complained by the end users that the business process failed, then the process of the fault locating and the recovering began. As we know, there are several departments in IT in the bank, including line of business team, application team, network team. They all have different perspectives to the problem. So when the fault happened at 1912, each team was using different tools and methods, follow different fault locating process to solve the problems. For example, the network team may ping the device at first, then check logs and the configurations of each devices. If those operations cannot solve the problem, they may use a tool to capture the packets, filter and analyze them, and repeat action on every device involved. But those actions may take a long time. So when they locate this problem, it's about 60 minutes later at 2012. After that, they took 2 minutes to recover the problem, and it took 2 hours, even longer, to finish the statistics and the fault report. The application team and the line of business team may run a similar time-consuming process, and it took a long time to locate and recover that problem as well. But the serious thing is, the impact of the fault was growing higher and higher while the time was going by. So here, let me show you the better fault locating process of our joint solution. This is an ECC screen that NetEase built for the bank to analyze the general information of new online loan product and the running status of the business system as well. The top center of the screen, this is the total transaction amount today of the new online loan product and the new business system running status in different data centers. Also, it's shown the transaction status, transaction trend analysis, transaction details information on the right of the screen, as well as the transaction response time, important information, and the daily trading information on the left of the screen. In the window of important information area, it has shown that the online law business systems was launched successfully at 0 o'clock and finished first 100 million transactions at 9:35. Congratulations! At 1912, the system prompted that the average response time on the online loan business was too high, exceeded the threshold and triggered an alert, which may cause obvious experience decreases to the end users. In the meantime, an administrator of the online loan business drilled down from the ECC screen to the service status board. This is a dashboard for all critical business systems of the bank, and showed that the running status of each business system in the last 30 minutes and will turn the timeline into red when there's something wrong. So he clicked on the timeline at the abnormal time of the global view to open the service path view and check more information about the fault. In the service path view, NetEase showed the connection between the application node of all business systems and the real-time performance metrics, including transaction volume, response time, success rate, and the response rate of each node. Also, the administrator saw there was an alerting prompt and a new financial system node, which provided a new online loan product service. The alert was precisely triggered at the application node that caused this problem. According to the operation result of an AI algorithm, the feature has natively integrated in the system. When the business system turned abnormal, NetEase could analyze the metrics of every application node and locate the root cause of the phenomenon automatically to shorten the time of problem locating by human being. Also, he got more details about the alert by clicking the alert icon in the upper right corner and see the average response time of the business greater than 1,000 milliseconds, which definitely exceeded the threshold of the response time and triggered the alert. Then he turned on the network condition switch in the service path view to show the network layer metrics between the new financial system node and the neighbor node, and saw that the network connection status was conjunction between counter ESB and the new financial system. The increasing business response time was caused by this. This diagnosis result has been also automatically analyzed by NetEase AI algorithm, which could split the total duration time of a transaction flow into network time, server time, and client time to predict the problem layer intelligently. Further, the administrator jumps from NetEase interface to iMaster NCE Fabric Insight by simply clicking the floating window. At last, Fabric Insight showed the end-to-end network path of the abnormal system, locate the root cause of the quality of experience event. The queue buffer of switch named Server Leaf 2 was too high. In the traffic analysis page, the administrator saw the customer service system were doing the data backup at alerting time, which caused a traffic burst on the switch, resulted in the conjunction of the switch queue buffer. So far, the whole process of the fault locating by the integration of Huawei and NetEase took only 3 minutes to finish the diagnose, which was 10 times faster than the traditional process and saved lots of human resources comparing by using the traditional tools, extremely enhanced the efficiency of problem locating and recovering. So Huawei and the NetEase business level AIOps solution is to simplify the process of fault locating and recovering, and to decrease the impact when a problem of business system happened. By deploying the solution, each technical team can informed by an alert of the event on ECC screen at 1912, earlier receiving the complaint from the end users. Then they were able to locate the system node by the real-time service path view in NetEase systems and locate the precise device that caused the problem in iMaster NCE Fabric Insight by the integration of the smooth workflow. At fault analysis and the locating action could be done in 3 minutes. After that, IT department will take 2 minutes to recover this problem. Also, an analysis report can be generated automatically, which may save a lot of time. So this is Huawei and the NetEase business level AIOps joint solution, which can provide the end-to-end operation efficiency analysis, support fault location, and quick troubleshooting for legacy and the modern architecture from business layer to network and the device layer. NetEase joining hands with Huawei hope to help the global customers to accelerate digital transformation and create a new advantage of the digital economy. Thank you for having me here. Good luck.
Thanks, Mr. Wizard He, for your informative speech. Well, That brings us to the end of today's session. We'd like to say thanks again to speakers for their wonderful speeches and also to our audience for active participation. See you next time.